Hi, I'll be going over the Umpire process for natural language calculator. So you're working on a very small part of a natural language processing engine. You want your engine to be able to respond to math properly. Your colleagues have written a program that can identify when a user is asking a math question, but they haven't written a calculator. Your job is to create a calculator that will parse natural language and speak in natural language. To simplify the problem, you will only ever receive two operands, and all operands will be under 100. So in the first example, we're given add 2 and 7, and then we want to return 9. We're also given an explanation that dictionaries can hold any value, including functions. And then in the second example, we're given a statement where we want to subtract 6 from 4 and return -2. Okay, so it seems kind of straightforward. We're just getting a string, and then we want to actually perform the operation that that string gives. Okay, so this is a pretty long problem, so I'm not going to type everything out, but I'll go over the solution. So first, we can create a dictionary for quick lookup for the numbers, from numbers to words and words to numbers. Then we can define four helper functions, add, subtract, multiply, and division, to perform the operations that we see in the string. Then we can create another dictionary so that when we see those words in a string, or just for a quick lookup, we can do those operations quickly. Then here we have the text to digit function. So we just split the word over spaces to get each part of the number in the string. So in case we have like a double-digit number, and then we can initialize this sign variable in case our number is negative. And then here we check if the string has the word negative in it, indicating a negative number. And if it is, we change our sign to a negative number, and we get the words after the negative number, which will be the number, or after the word negative, which will be the number. And then we check to see if the current number is in the dictionaries that we defined before. And if it is, we just return the number in the sign. But if it's not, we use the split function to get the tens in ones place. Then we join the tens in ones place in one number, and then we return that number. And then here we have another function where we can convert the digit to words, so the number to the word. So we do the same thing with initializing the sign variable. And then we check if our number is negative. If it is, we change our sign to negative, and we also get the absolute value of our current number using this line right here. And then so we check if the word is in our previous defined dictionary, and if it is, we check if the sign is positive, then we return the word. Otherwise, we make sure that we return negative with the word. Otherwise, if it's not, we directly get the tens at ones place from the number that we're given. And then if it's a positive sign, we return the string positively, right? We don't use the word negative. But if it's negative, we return the string with the word negative, indicating a negative number. And finally, in our implementation here, we split the statement, the string that we're given over spaces, and then we check what the operator is in the first part of the string. If the operator, so we have two cases here. So if we go back here and check, so let's see. So we go back to the problem description. So if we look at the vision, um, we need to make sure that we get the ones in the thirds place. But um, if you want to subtract, if we look at subtraction, right, we want to subtract from the thirds and the ones place. So, so that's what this check is here for. So if we see the operator divide, we can just get the ones in the thirds place. But if we see anything else, we get the thirds in the ones place to make sure that we do the subtraction properly. Then we just use the functions that we defined before to convert our numbers from words to numbers. Then we get our result number. We change it from translator from its current operator into the first and second number, and then we get the result word in a digit, and we just return that word, indicating, and then we have the number converted. And thank you. That's my implementation for our natural language calculator.